Okay, let's start the session now. So before we start, uh, how many of you have gone through with the content of week one? Like this is a totally new. You'll feel a different topic also, and this is a subjective paper. Okay, so means your exams are going to be subjective. Your quiz one, quiz two, and in some all are going to be subjective, where you will get some objective type question, maybe 4 to 5, 3 to 5 even I can say, and sorry, objective question, and the rest all maybe 3 to 4 question would be subjective. So in the subjective part, you can choose only the objective part, you can choose only the options, and the subjective you have to write the detailed solution. And also, if you want, you can, if you are not very much sure with the object in the objective type question, you are not very much sure that which option is true, best way to get the partial mark related to that, you should to write the explanation, whatever the option wise you can write the explanation. This is why this is going to be true or false. According to that, you can choose. Okay.
Sir, what you told about the parcel mark thing? Can you tell again? I didn't understand.
Okay. So the partial mark mean to say there are two sections. There is going to be two sections in. There are two sections in the question paper. The first section is going to be objective, and the second section is going to be subjective. The first section objective is if you want to get the partial mark in objective and the subjective also. If you write some steps, you will get surely, if the steps are correct, you will get the partial mark. And in objective, if you write the options explanation why this is wrong, this is true, so this will also help you to get the partial mark. So, mean to say, if you write the explanation of the objective type questions, then you will get the partial marks. This is how the way. Okay. So, and also your assignments, practice assignment, graded assignments are some of the weeks have objective type and some of the weeks are subjective type. Like first 2 week you will see the objective type, before you may get subjective type. So to get the flavor that okay, how you will write in the quizzes and in term, but in term is going to be full subjective. It is not going to be on computer based. Okay, you will see questions on screen, but you have to write the answer on answer copy. So this is how the quizzes and in term will go.
So, hello.
Yes, yes, boss.
So, NTM only will be subjective and quiz one, quiz two.
Both, all. Which
Okay,
one is
all.
also subjective, which two is also subjective, in term is already.
Okay. We need to write the solution. The written paper will be there,
Yes,
not
yes.
computer based.
Yeah, so first 2 weeks you will get objective type here. But the 3 and 4, as you are able to see the questions in assignments, exactly the pattern is going to be same for which one and which two and inter. Which one, which two and inter.
Okay. And okay, today is the first lecture, and we're going into the new territory for M2, and they're saying that new topics and new something will be there. So,
Yeah,
can
so
you just guide us the path for us to follow to good day in the depth and have good scores and to get the good knowledge of the all the things and all that. So, pathway that we should follow. That
okay.
will be the best pathway. So, as earlier batches are there, you may have some experience of the earlier students or some thoughts in your mind that it will be better to us
Yes,
to
yes.
follow.
So one thing you have to always note it. Uh, the best way is before to coming in live session, please go through it at least once the lectures. Okay? At least one, so that you will get an idea to all of you that whenever you are coming in in the session, please go through with the content, so that whatever we are going to discuss there, you will at least listen here something is some bit you are aware about that okay, this is the at least
Right, right.
uh, knowing to be, what is going to be the syllabus within the particular week, and not only the week, some idea you will get. Okay, if some term is coming, let's say here in the week one you will see the vectors linear combination, so at least you will hear from the lectures that okay, some linear word is there, some vectors is there, so linear equations is already, I think, no, we'll discuss here. I think it's yeah, linear system of linear equation is already discussed. So you will see something. This is whatever the new things are going to be here. So you will at least listen these words. So this is my request. If you, this is a minimum requirement if you are coming in the session. If you are multiple time you like in the lectures, activity questions you have solved, practice questions you have solved,
Hmm.
yeah, and then coming in the session, so that will be more beneficial for you, so that whenever we are discussing, you may ask the doubts, whatever the doubts is coming in your mind. Could you mute, please? Yes. So whatever the doubts is coming in your mind, or uh, whatever we are going to discuss, you will understand more in comparison of who didn't see the lecture, or even he see once at least the lecture. You will be more in understanding the part or other things. And also even sometimes uh, the concept would be if you have seen some new type of idea you get while solving, while discussing, because you have solved some activity practice problem, then while discussing you may get some student may not get that idea, maybe you will get new idea in that while discussing. Maybe within that we are while discussing you got something and you argued with us something, okay, how this could be done. So these all challenges or the new ideas you will understand more if you do yourself before to coming in the session. And this is good for us also, so that it will be a more interactive session. See, if
Right,
I will
right.
start, I only start like whatever the contents are there. I just mention that okay, this is the consent, this is the topic, this is the consent, and you all of you are continuously listening. You are not saying anything that okay, why this is, how this is. Could you repeat, please? I didn't understand. So if you not ask these questions, this is like I am just speaking. I am myself. I am listening. You are just very silent. Like previous batches are do like this, and that is a totally bad thing. I feel uh, that at least students should be interactive. If you come, if you see the lecture, then your
Hmm.
doubts will come in your mind, and the session will be more interactive. I will feel also fun that okay, while discussing with you, that okay, students are showing interest, they are engaged with the session. So this will help us to even help us to discuss more detailed things in the whatever in the even beyond of the lectures. We can discuss something that okay, which may be helpful for to solving the problems, understanding the concepts. So
Right.
this is
Okay.
my request to all of you, that before coming to the session, please go through with the content, so that the session should be more interactive, more discussing, and more even the challenges problem maybe I will bring. So this will help us also to discuss more and more, and you will also get benefited, not only so others also get benefited. If see sometimes one student used to get at least he gone through that, he asked more and more questions, other student also get benefited, okay, these things are happening. So don't make it a monologues, make it as a uh, fruitful discussion session. Okay? Not only the way I am only the teaching thing. Okay, this is don't think we are doing the class. Okay, I am not teaching you. We came here to discuss the concepts. I'm not here going to teach you. This is the session means, because already the teaching is done in the lectures. The best way is even the that teaching thing is already in the lecture. That's totally fine. But whenever you see even the offline courses also, if teacher is not teaching, he is discussing everything with you. That is a more truthful in comparison of just he came, taught, and went. That is not even, I will say, to a waste of time, because what, you will just listen, write your note, that's all, and he went and you went to your home. That is not, no. If you are discussing more and more, the new ideas, new techniques, new thoughts will come in mind. Others will get benefit, not only others, you will get benefited. The teacher will discuss more and more depth, or not only the depth, in a wide range of things he will bring in the session or the class, so that you will get a very simpler way to learn. So this is the thing, because these things, why I am repeating more, I spend it 10 minutes on these words. Why? uh, Two or three batches are, they are very very silent, and that's impact very bad us on that. What we can do, how the student will learn more. If you're not asked, we will come also, will write something and then we'll go. Okay. So please make more interactive. To become more interactive in the session, you have to at least see once a while or two. I am suggesting, at least requesting, I am requesting at least once you have to go through with the lecture. Okay.
Okay, sir.
Any other doubt? Anyone to say something, suggest something, or
And we need to submit the handwritten solutions for all weeks.
yes? So yes. So first 2 weeks you have, I think you will do on portal. Okay.
Okay,
First 2 weeks you will submit the graded assignment in a portal.
only.
Just click on week 1 and 2. Yes.
Okay, okay.
And
So this will be objective. First 2 weeks will be objective.
objective. You have to submit answer just by clicking which option is true. It will be shown in the portal wise, but 3 and 4 maybe onward weeks would
From the
be
week
uh,
third onward, we will get the link to upload the work assignment, right?
right, right.
PDF.
So what is the way there? Lavanya will tell you in more detail. She will maybe she will join. She will conduct live session. No, no, I'm not giving the surety. Maybe she will sell the detail in the group. Even the how you will submit your assignments. She will tell you everything. First 2 weeks are already we will be done in portal, so no need to worry for 2 weeks. 3 weeks onward, 3 week week third, you have to write your, so the way it is, you will open the, let me show you that. Like suppose I am opening the week 3 here, so you will get a, I think this is, yeah, you will get like here, please find the link of assignment. You will just click on there, you will get a PDF of the week 3 questions credit assignment. So you have to see it, you have to find the question, you have to write your own. Okay, you have to write on your own PDF or whatever the digitally you will are able to writing, or maybe handwritten, whatever way you are, just write the detailed solution of it. Okay. So below of it, see here it is somewhere, submit the work, it's already over, so it is not showing me the link. It's older portal, but here it will show you a, like here it is as it is becoming blue. Similarly this will be also a blue, and it will be reflect to a Google Classroom. If you click there, it will reflect to a Google Classroom. Okay, there you have to, it will, the option will show there somewhere here on the corner side. Okay, upload your solution, upload the assignments, whatever the things written, you have to upload there, and you have to do turn it. Okay, you have to do turn it finally, like you are doing the final submission, right? Many people, many students used to just upload and they are thinking they are done. No, don't do that. After submission or after uploading anything, you have to do, so you have to submit, right? So after, like here uploading, in place of word submit, the word it is there, turn it. So you have to just click on. If you do turn it, then that means you have submitted finally the data assignments, transcript, solutions. So don't forget to turn it. Okay, without that you will, if you upload, but it will not reflect us to reach the PDF. Okay, so do turn it finally, the do the final submission. That means that is the mean.
Right.
Sir, one more doubt about peer reviews. Can you
Hmm.
briefly
Yes, yes.
describe it once? Or how, what is the process and how we can do it with more accurate manner?
Ah, okay, there is a peer review. Okay. Mm. Uh, I think in this course, I don't think there is going to be peer review, but I will not confirm it here. Okay, I have to ask first. Okay, and the peer review is that maybe some set of question paper like after the due date. Okay, after the due date over, when the due date is over, then you have some set of question paper you will get, some other standard different question paper, and you have to check the others question paper. That's how you'll have to do. And finally, how much you got means, I think marks or something you have to do, you have to review the others copy, and finally you have to submit. This is how it is. The detail would be shared. Okay, no need to worry. I think for maths 2 years there is nothing such, there is no such thing. But if it is there, let me confirm from Lavanya. Is the lead of the course, so she will know. But as of now, I know, I don't think that here is it is. If it is there, I will confirm in the next session, or maybe I will share in the already Google Spaces there. The detail would be given there. Okay. And
Okay, sir.
also,
Okay.
not only it is happening or not in the conformance thing, everything like how you will do the peer review we discuss. So the student will also know how it will be. But the layman term, uh, you have to check the transcript, or means assignments, answer assignments of some other student, and you have to submit. That's how it is, the peer review. But
Got it, sir.
I don't think it is
Okay,
here.
got it.
So generally it is, generally it is objective type courses. It is like some other courses you have, where the objective type course it is. But here it is already subjective, so I don't think it is here. Here it is going to be peer review. You need to upload the link of it. No link. No need to upload the link. You have already, it is space is be given. No, there is a space already given, as you know. Maybe I'm not able to show you, but it will be, there is some space or some option would be like here it is. No? If you click in the discussion forum, maybe I don't know where it will go, but it will be give the option to upload. So no need to give the link. It already give a space where you can upload your PDF. Okay.
Right, sir. And the question is that from my side is that, as we given that activity questions, practice and grading assignment questions are there. Okay, so that much is sufficient to do well in this course academically.
Yeah, I think
So
so. If you, yeah, as the at least activity questions are there, the practice questions are then. Uh,
grading,
yeah, graded assignments already you have to do your own. But
right,
yeah,
right,
practice and
right.
graded, sorry, practice and activity questions are enough to do. If you understand the concept, then
Mm-hmm.
you have to just practice yourself that okay, using the activity and practice question, that okay, I understood the question, I am able to solve, I
Right.
understood the concept and I'm able to solve. See, whenever already all of you are graduating now, maybe somewhere offline or here only, we are already in the diploma course. So
Mm-hmm.
the way it is, like whenever you are understanding the concept, the way it is, do some problem yourself, so that it will be give you a more. Could you mute please, firstly? So it will give you idea that okay, you are able to understand properly, like while solving. See, sometimes if you see the lecture, okay, the way it is, even sometimes I used to, not sometimes, when I was studying I feel it already also, that okay, teacher came, taught, okay, and I, okay, after listening everything I understood, okay, this is how it's going. But I didn't practice, I didn't solve any problem, I just understood the concept. So what I faced finally when I came to in the paper exam, I understood the concept, but how I will solve the problem, that is the big challenge. It will come in front of you. how I will solve, how I will write. Okay, you understood the concept. Like for example, you understood the linear combination or maybe basis of a vector space. You understood that okay, it is some set of vectors which is linearly independent and span the vector space. This is how you understood. Suppose you understood the concept, but the question would be asked like, let me do the open tab. So let me give an example. Even if you don't do the practice, suppose there is a concept basis in vector space. Okay. So you suppose you understood this concept finally. Okay, what is a basis? So the concept here, it is linearly independent thing and it will span the vector space. This will be the vector space. It is a some set of vector. I will tell you. I will now we are going to discuss this concept. But the thing is, the question is asked. Maybe there is a vector space is given. Okay, and the question is asked. Find the basis of the vector space P. You know concept very well. I am also agree with you know the concept, but find the basis of this vector space. Now from here you will start studying. Okay, suppose you solve one or two problem, but you didn't practice well, then your speed is going to be slow in the exam. It is going to be slow. So that means you will take more time. So generally the question paper for maths 2 1 hour is given. So you will take 1.5 hours. It will impact to other courses question paper. So that means you finally came in the and feedback if you'll give us, you'll give okay, the question paper is lengthy, but you didn't feel that we didn't. So you didn't feel it. Okay, you haven't. This is the lack of practice. But this is exactly the lack of practice. If you don't do, you will do question. If you understood the concept, totally fine. But your speed is slow in the exam, going to be slow in the exam, or maybe you are not able to solve the problem also. These two things going to happen without the practice.
Right.
If you understood the concept and did some problem, at least whatever the graded assignment, practice assignment, not only see the solution, not only see the solution. Okay. You have to don't do this like even write, take pen and paper. Okay, at least okay, you have seen the solution, understood also, change some number in that if you want, or itself again after 1 or 2 days. Okay, again see the question, the same question, and try to write your own. Okay, so that at if you are because you understood the problem, so there is no, I will say you are not remembering it, but it will be enhanced or okay, this is how it's we have to solve. Okay. And if you're trying to solve some new question, that is a plus thing for you to do in the exam very fast manner. See, if you are thinking to pass the course, this is how you want to try to get the good marks, good grade in this course. So I will suggest that try to practice here question papers. If you have some books are already reference, right? If you are now doing a institute here, you are doing in, this is not a 11 12 course, so this is a graduation, you are doing graduation. So in graduation, whenever we used to get syllabus, some reference book also generally given. Okay, so professor not will say you to go through with the book. He will not say you that okay, solve practice or problem from there. He just given in the syllabus, okay, this is the reference book, he came taught. It's your responsibility to get that book, read that book, solve some practice from there, so that you well understood the concept. So this is not 11 12 that okay, he will give some assignments or these things are no. Now you are 11, no, this is not 12th standard, now you are graduating. Okay. So he will not force you to do your, this is your responsibility because you are learning, you are building your career. So this is your responsibility to practice. Yeah, what we can do here, if you are not understanding, we are already the fixed day, we are discussing here. Just go to, if you are solving some book from some book, if you are stucking somewhere, brought that question with us. Also, we will also start discussing, okay, this is the problem, okay, let's discuss how it could be solved. See, this online course is even more, uh, this online course is better in comparison of, in comparison offline. I'm not promoting, this is not promotion, this is why I'm saying, because here the benefits of live session. After the lectures, once you see it, you may not discuss with the professor, you will not get time, he don't have time to discuss with you. But here we have a mentor, we have a instructor here, or even if you demand some more and more session would be kept, so that you will practice yourself and come with, if you're not understanding, let's discuss here. Means more and more discussing thing is available in this online course. So even I will say the better in comparison of offline, because he came in the offline, he will just came, he will come, teach and go. Okay, in whatever the within the class time you discuss, that's all. But here, not only we have one session, two or three sessions, on demand session you can keep, ts session going to be there, more and more sessions are there. Any of the session you can join, discuss the concept, that's all. And not only, and not only uh, sorry, not only the instructor sessions are there, ta sessions, and not only the tas and sessions are there, already this course is there. I forgot to mention that there is a discourse also, where you can bring the questions, you can post the questions, maybe some other student will also help you to solve that problem.
Right, sir. Right. Noted.
Yeah, so this first 2 weeks, Surya Prakash is saying there is already there the peer review for week one. So yeah, this is why it is week 1 and 2 are objective. So maybe you have to write your handwritten, like the thing is that whatever you are, see, you have to handwritten, you have to submit your rough work also. You know already some other weeks, some other courses you have to submit your rough work at least. Okay, this is how it is, this is what you chooses, and you have to submit your. So week 1 and 2 are objective, that's why it is there the link, you have to submit your handworks. Okay, I think doubts have cleared. Any other doubt? And the way it is to learn the course is, I think this is much, I discussed a lot more. I actually a bit upset with the previous batch that they were not, uh, they used to very silent, they don't make interactive session. So please, my request is that make it interactive, ask your doubt. If you are not understanding, don't ask in the chat like he is saying. Even you can unmute, like Suru Prakash have asked that, okay, he wrote in the chat, I will prefer unmute yourself and ask in front of me, this is the doubt I have. Don't write in the chat, because I can see. The reason I am saying, if I don't open the chat, I am not able to see, okay, while discussing. So better is that, suppose I open this page and not able to see what you are saying, you posted some question on the chat, so I don't see, I'm not able to answer you, and also I don't get feel like interactive. So better to unmute, okay, and ask the direct question. Don't feel it as like, as in the school or maybe some graduation, there you don't used to ask uh, the questions from professor teacher, but it is not like, don't make it like here. Make the interactive. You can unmute, just come to, I am your friend, okay, I'm not a teacher, okay, I am your friend. As you used to talk with your friend that, okay, I have this doubt, let's discuss this, please with me also. it will be more helpful for me. Okay, I am saying I am not a teacher, I am your friend, I am came here to discuss, I am not came here to teach you. Okay, so whenever you are like as your friend, you whenever you are discussing something, you don't ping on the WhatsApp, okay, tell me this. You directly speak right in front of you, okay, I have this doubt, yeah, let's discuss this one, why, how we are getting. So do with me also, don't ping in the chat, directly ask me. So it will be make me feel better, right? This is how I like, this is a boring thing I got from the last batches, but this is a request from my side that please make it interactive. If you will speak, I will get feel better, okay, you are speaking something at least. So let's start, like 30 minutes we spent it here on uh, some motivation I have given. Okay, so sorry for that, but it is
No, no,
if you do it like that, that is a good thing for me
no,
also, for
no,
you also.
no. It is very
But
useful
sir,
for us,
I
all of
missed your
us.
introduction.
Sorry.
I think I missed your introduction. Can you introduce yourself?
Yeah, okay,
Back to you.
so okay, I am Shubham. Okay, I joined with the maths course ID, but myself Shubham Maurya, and I did my graduation from Could you mute, please? If you want to speak, if you mute, this echo is happening. Okay, thank you. So I did my graduation from Banaras Hindu University in mathematics. Okay, and masters from IIT Madras itself in mathematics. And onward, I joined this biggest degree. Okay, this is the from starting when this course even the DSS is started in 2020 in September. So from that time, I am teaching here the math courses, not only math courses, in DS also machine learning courses I used to teach. Okay. This is a bit
Great,
about
sir.
myself.
We are excited to learn from you.
Okay, thank you. Thanks, Jay. Thanks, everyone. So let's start the topic. So this was the first session, so that's why I didn't make any note here. I came and let's discuss the thing, whatever the things in the lecture. So maybe from next onward, I will make a PDF and then we'll discuss there. But this is the first session, so let us start. The simple topics. So like the first lecture is real number and complex number. So the first lecture is just an introduction about the course. So I didn't tell you the broader way of the course. Okay, so let me discuss the syllabus a bit about also, so that you will get a map that okay, what is in this course. Okay. So here in this course we are going to see a new topic, which is a vector space. Means here if you see it, the name of the proper word of the course is going to be linear algebra. Okay, why it is linear algebra? Because the here the most of the things even you will see the functions. Okay, not only let me make it two ways also. Equations you will see. Okay, equations generally in this form, ax plus by plus c z is equal to d. So these types of equation can't linear equation. I think it's already in maths one. Solving the linear equation is, I think, there. If not, so this type of equation may be not only one equation. You may get two equations also. Let's say this is a1 b1 c1 d1, and let's say this is a2 plus b2y plus c2 z is equal to d2. So let's say I have two equations simultaneously. Okay, I want to solve this. So this kind of these two equations simultaneously I want to solve. So this is called a system. This is called a system. I have two equations I want to solve. This structure is called system, you can say. And if you see the separately equations, these equations are linear. What it means linear? Linear means here the degree of the variable. These are the variable, right? X, Y, Z. These are the variables. So these variables have degree 1. It is not a case of this one, ax square plus by square plus cxy plus, okay, or maybe z plus d of xy is equal to some constant. Okay, let's say. So see, this is not a linear. The reason here, these are the variables we have, and these variables are not of the degree 1. These are the, this is also a degree 2. Okay, this is a degree 2 term. So separate terms, this is called terms. You can say these are the terms we have. These are the terms we have. And the terms are added by the addition plus. Okay. Okay. And these are called the coefficient. This A is called coefficient. Okay. These are called coefficients. This is called variable. Okay. These are the variables. Similarly, this one and this one. So these variables here is not of degree 2. These variables are, sorry, these variables are not of degree 1. These variables are of degree 2. You will say this is a variable we have of degree 2, sorry, degree 1. So this equation is not of degree 1. So the reason is, if you see it here, the all terms are of degree 1. But here some terms are degree 2 and some terms of degree 1. So the whole equation, if you see, the degree of the equation is 2 here, because what is the highest degree have the term have the degree, okay, that is going to be the degree of the equation. So here each term have degree 1. So that's why degree 1 means here linear means here you can say the degree is 1. Okay, for the time being, you will see in more detail what is the linear means. Okay, there is also a different meaning when you will see the linear transformation, what is there. And also the linear is, it came from the line. Okay, it came from the line. So if you see it here, if you remember the coordinate system which you have studied at least in 12, because all of you from maths background, the years generally take the maths background student. So if you see, this represent a line, represent a line in the coordinate system. So from there you can relate this line, it's represent a line. Okay, so here the terms are also of degree 1. So now this is of 2 variables is there, we can extend it also. We can extend it, so maybe 3 variable, 4 variable, you will see in more detail slowly. Okay, so from here you can relate it that the linear word came from here. Okay? That linear means have degree 1. The terms have degree. Okay, and this is the whole equation, it is called linear equation. The each term have degree, and this is a linear. And system of linear equation means we have either only the one, you can call it as a system of linear equation, or maybe more, 3, 4, 5 till n. So more equations may have. And I want to solve simultaneously. What is the meaning of simultaneously? Means whatever the value you will get of variable x, y, z after solving, it will satisfy all equation, not only one equation. If you substitute here the value of x, y, and z, it will give the d value d1. And if also you will substitute the x, y, and z value here, it will give the d2 value according to the coefficients, multiply, added, whatever things. So it will satisfy the all equations simultaneously. Okay? So this is the meaning of, you can say, system of linear equation. Is this understood? That I think what is a system, what is a linear equation, what is a system, and we are solving it. Okay, so the linear algebra is came from here, and the second is a function also is there, like we have studied x square, x cube, something you have studied, like these are called functions generally in the layman term. Maths one is already it is taught function, you know. But the case is, if you think of a function of this case, let's say I am putting a 2 variables. Okay, not only 2 variable, x plus not x plus y. I am giving input as a 2 variable, and I am writing like ax plus by. Okay. See the here of this type of function. You have studied a very this kind of function, but see the very differently. The input is of 2 variable here separately. Okay, and the output is of this case. Maybe output maybe of also coordinate wise. Let's say d of something, and let's say sorry t of x plus e of y. The output also you got as a coordinate wise. You're giving it as coordinate. So don't fear it. We'll discuss in more detail. I'm just giving an idea that each term is also a linear. See, there is no degree two terms. All are of degree one term. So from here you can say the linear is come from the, because we are going to do if we play around these all. Okay, if you think, if you see the whole course, we only deal with such kind of thing. Only these two is the main key role, solving the system of linear equation and this kind of function. This is called linear transformation. This kind of function, the whole course, linear algebra course, is play around only these two main topics: solving the system of linear equation, understanding the terms you are looking, no basis, dimension. These are all actually, you know, if you think it, the software and hardware computer, if you have, right? So software is, you are able to play on, very, like writing the coding or whatever the thing you are, applications are there, these are called software. The hardware, the behind of thing is, everything is happening on memory, battery, system, whatever the electronics things is there. That is the core thing, and software you are doing. So here you can say this is the hardware, this is the engine of the linear, solving the system and this kind of function. The software, you can say the application is basis, okay, span, is what on this behind it. Anyhow, if you start solving related to this problem, on behind this you have to solve, or this you have to solve. So this is an engine, this is hardware, and these are terms you can the application software. Even the whole vector space linear algebra is on this. So that's why you are going to play with the linear things, and algebra means doing the algebra means playing with the numbers, okay? Adding numbers, variables, that is the meaning of algebra. So you are going to play with this linear kind of things, and you are going to do algebra, okay, with these kind of things. That is the thing is going to be linear algebra. So the whole week 11, 12 till week 11, 12 is on this, okay. And uh, the week one is, so here is, let me tell you that there is a two section, okay. So even you have to uh, yeah, before to start this should be needed to know also, the our whole course is this course is divided in parts, okay. First thing, okay, let me in the syllabus, if you see the syllabus, okay, divided in two parts. So it's also given in the week wise also. Week wise, it is not like week 1 to 4 is a different syllabus, week 3 and 4 is a different syllabus. It is not like that. It is a per week, you can say, or maybe combination of week it is. You will first study the vector space of R2. Okay. And the next day is you are going to study R3, or you can say Rn. So what we will do, the first 2 weeks, we will understand the concept on R2, okay, and the same concept we are going to understand on R3, or you can say Rn. Same concept, even same concepts mean, I mean to say, no, I am adding the word concept, right? Same word is there. I'm saying the same means exactly same. Whatever the basis word you listen in R2, whatever the meaning of the basis, that is the same meaning is going to be for R3, R4, or Rn. No difference, no wording change in the definition even, and the not intrinsic meaning of is also going to be changed. Why? Because whatever you are going to do in R2, just extension is you are doing, like extension in the mean of is you are studying the R2 is kind of this one. So R3 is 1, 2, 3. Three coordinates going to be. If you are saying R5, 1, 2, 3, this is R5. So whatever the concept is here on, the same concepts will apply on this. Okay. So no need to worry. Why this course is built like this? The reason is playing or learning on R2 is make more easier. The reason is you can visualize it here. Everything you can visualize. You can see by the lines, by the planes. Okay, you can understand by this. Once it will go beyond of 3 dimension. It represents a dimension. Okay, this is a dimension called R2. 2 dimensions. When it will go to more than 3 dimension, then you cannot visualize. Then it will be some. Then you may get tough. You feel it tough. That okay, it is going to be tough. But if it is until R2, if you understand the concept of base is okay. Let me write even that if you understand the concept. I'm just saying, I'm not going detail, I'm not teaching anything, I'm just explaining the syllabus so that it will map in your mind that okay, we are going to study like this, and it will help you to understand the concepts. So in R2 we will study the linear combination. Okay, linear combination, span, basis. Okay, basis, linear transformation. Okay, linear transformation, matrix representation of this linear transformation, and range, null, left null. Okay, null space, these are the range space, null space, left null space, 4 fundamental space. Okay, maybe inner product will see. Okay, so even eigenvalue, eigenvector, eigenvector. Okay, eigenvalue, decomposition. Okay, sorry, decomposition, diagonalization, power matrix. Okay, yeah, I think these are the, so these concept is going to be, you will see in R2. Okay, these are going to be seen R2, but exactly with the same meaning, with the same definition, no change in the definition also, you are going to see for R3 or more than 3 dimensions also, exactly same. Okay, so that it will, the first we'll understand it. So week 1 and 2 are going to be very similar. You are going to study, you will see the week 1 is going to be of this linear combination. So vector space is there first, vector space, the linear combination, span, basis, change of basis is also there, change of basis is also there, and maybe matrix representation, range, null space. These are all going to see week 1 and 2. And 3 and 4 you are going to see the same till here. Maybe you can check even the linear, yeah, matrix. These things you are going to see within week 1 and 2. So this is, let's say this is week 1 and 2. So the same thing is going to see for week 3 and 4, same thing. But here 3 and 4 you will see for dimension, mean to say for R3, R4, maybe what is generally saying to be Rn. You will see the C in Rn. For week 1 and 2, you will see only on R2. These things you are going to study on only on R2, but 3 and 4 you are going to see for Rn. Okay, so this thing, if you map in your mind, so it will help you to understand the self, no, concept very easily, and it will it will make your mind that okay, we are going to see first 2 weeks is like this. We will understand in more detail with the visualization, and then 3 and 4 if you're not able to visualize, but yeah, concept are going to be same. So why this is broke in this way, the reason is the main part is visualization and calculation. Means it will make easier to calculate everything easily. Okay, sometimes you, if you do are doing the calculation on a bigger matrix, then it will be tough. Maybe 3 4 it will be tougher, but if you play on only 2 cross 2, will be easier for you because there are going to be 4 numbers only. For 3 cross 3 it is going to be 9 numbers. So so because of this calculations visualization part, because of this is how it's broke in 2 parts, so that you can easily understand it. So is this clear what I'm saying?
Yeah.
Understood?
Yes, sir.
Yes, sir. Yes.
Okay. So now let's start topic. So okay. So even okay. So even I till now I didn't finish the syllabus. Okay. Let me a bit detail also. Slowly you'll get the syllabus also. So something so same way like week 5 and 6, week 8 and 9. Okay, week 8 and 9. We will see maybe some repetitive concept also is going to be okay. Some repetitive. Maybe you will again see the same concepts. Okay, maybe with the different approach. Okay, so slowly you will get the idea how it is. Uh, okay, once you will see. But this is the at least for 4 weeks. This is the syllabus. Okay, and this is what it is. Yeah, some more things are also come inner product. Okay, 9 10 11 10 some inner product will also there, means dot product. And there is a circular matrix is there. And circular, after the circular matrix there is a discrete Fourier transform is there also. But we are not going to study in more detail, we only just see the basis of it. DFT is there, that means okay, DFT is there. So only the basic thing, because now the more things are removed. I think you have also heard that okay, some syllabus have changed is there from the previous term also itself. The main part is discrete Fourier transform have removed from the syllabus because it is needed for, maybe it will be done in the maybe head courses. I don't know when it will be. Professor will decide it. But this part is removed. So only the basic, very basic thing you will see. Also some operators, some normal matrices or different type of matrices you will see. So see, the main core idea is these all. If you understood these all topics, whatever here and this here, okay, within 3 and 4, and some inner product also a bit, then done, you are done. Then everything, now rest all things are going to be just applications. Something is there, not more than that. The core idea is you have to understand this thing, basic thing, this basis, linear transformation, matrix, this all. So before to start it now, this core means thing, anyone have gone through with this content anywhere, or have studied from offline degree? Someone, anyone is there at least who have seen these topics previously somewhere, or read your own? Yes, Aniket, you have gone through. Okay,
Yeah, yeah.
so okay, two, I think two of you have. Okay, this is a good thing. Ananya also. Ananya also. Okay, so where you studied, Aniket?
It was from YouTube. Some other
Oh,
lectures.
so so you are not doing any course somewhere. You studied your own.
Yeah, yeah, yeah. From books and YouTube.
Ananya, from where you studied?
So the old live sessions.
Old live sessions. Okay. Means okay, so you so who is two of you only didn't did the course, only try to understand yourself. That is what it is. I mean, you mean, sorry, you mean.
Yes, sir.
Okay, so now let's start now the topics. I spent in 1 hour on it. So this is the idea on it. This is a bit syllabus about. Let's start now the topic. The first topic is vector space. Even so, even the real numbers and complex. Let me discuss a bit real number and complex. Okay, so real numbers is you are already doing. You are playing on the real numbers. Okay, numbers are there. Okay, rational numbers, irrational numbers. If you don't know it, but mean to say real numbers are nothing but, if you think the representation of real numbers is, you can say the line is there, means if zero is the, you can say the neutral, and right side is the same, whatever the numbers are going to be there, the left side the number is there with the negative sign, and there is no gap in the real number, you can say. That's why it is a line. Okay, it is a line, mean to say, uh, if you say there is a number between 5 by 2 and 5 by 3, yes, this is true that there is a number in between them, so there is no gap between them. So the real numbers you are playing around, main focus is the complex number. I want to tell what is the complex number. The complex number is actually come from it came from, uh, when people used to solve equations like find the root of ax square plus bx plus something is there, some 2x square plus, or x square plus 5, find the root, or they used to find what is going to be value of that. If you substitute, we'll get the value, means here the root, I mean to say. So they reaches to the one thing is there, what is going to be root of this one. The main basic ideas from here, what is going to be root, what I will substitute here. So whatever the solution of it is, from here it generated the complex number, and you can say the, I will not say the subset, properly not saying to be subset, it is not a good thing in mathematics, but you can say the real numbers are, because why I'm not saying the subset, because the operations are changed here. Because here a different adding the numbers in complex is different in comparison of here. Okay, I will, that's why I'm not saying, going to say subset. But if you see the term wise or number wise, just number elements in the set, so you can say by that way it is a subset. So it came from here that, and if you see it, it is nothing but what is the solution of it, it is the -1 and root of it. If you see the x value is here, and this notation is, you can say, representing it as a iota I. This is a I, and from here I started thinking the complex number. Okay, because we can not, there is no meaning of 3 plus I5. You can add, not add these two, you cannot add. This represent a complex number. As you can see in the real number, you can add these two number, but there is no I there. This is it, but there is no meaning. This represent a single complex number. So from here the representation start, that let's say I have a complex number, I am saying, so complex number of, the representation of complex number is a plus ip. Any complex number would be represented like this, a plus ip, where you can say a is going to be any real number, and b, a and b both, and b also any real number. So this is like a, this is represent a complex number. Let's say I'm saying this is a jet. So I can say even, let's say this is a jet one I'm saying. So 1 minute. Yeah, Aniket, you want to say something?
Yes, sir. I had a doubt.
Yes, yes, sure.
So I have also taken the signals and systems course. In there they discuss linear systems.
Mm-hmm.
So the doubt is what's the difference between a linear system and systems of linear equations?
Okay. So sorry. So linear system and system of linear equation.
Yes, sir.
So linear so system in the signal and system linear system is they have their own they have defined
Yeah, they have
because
defined that those systems who follow the homogeneity and the additivity principle, those are called linear systems.
so because here and here the system of linear equation is this is the in the term of electronics, but this is in the term of math. So here the system of linear equation means you have some set of linear equations, some set of linear equation, and you are solving. Okay, that is your mean to say a system of linear equation. Here the linear system is totally different. Here this is the totally different. This is you can say, is there any mathematical representation of this? Have you remember it?
Yes, sir.
What is that?
The additivity principle says that the inputs, if we take a input, say x1, and if it produces the output y1,
Hmm.
and then if we give a input x2, and if it produces y2,
Hmm.
then if the system is linear, then
Hmm.
if we take a input of x1 plus x2, the output should be y1 plus y2 if the system is like follow the additivity
Sorry,
principle.
yeah,
Then
sorry, x1 plus x2, then output is going to be y1 plus y2.
yeah,
That is what.
it happens only if the system follows additivity.
Additivity and the
Yes, sir.
linear thing.
No, the linear is only happening if there is additivity and homogeneity together. So there is
See now this is the term is coming from the linear transformation. So this is you can say application is there.
okay.
This is application of linear transformation, which is a term. Application you can say, or even the application of system of linear equation you can say. Okay,
Okay.
which so that is I think that's why these two courses are co-requisite, right?
Yeah, yeah,
Not a
yeah.
prerequisite. This is a core. It means you will understand here also and there also. But both have so linear means that is what I said. Linear means this kind of representation means linearly added here. The input is linearly added, the output is linearly you will get. And this is one application of system of linear equation itself means of this case also and also of the linear transformation. So this is application means whenever now if your system is converted, that is what professor in maths one said, no, you have a context is given, you have to convert that concept in mathematical institution. Okay, means you have to convert that problem in mathematical solving, adding equations in that form, and you have to solve. So that is what you whatever you study in the electronic system term, you have to convert that in the mathematical institution. So, not institution, intuition. Okay, in mathematical institution. And in that, so if you convert that in this is what is there, you have to solve the system of linear equation, or maybe the linear transformation.
Okay.
Okay, so that is why in back end here you can, if you say the mathematical language is mathematics is the language of science, you can say, because the hardcore is thing whatever you context you are studying in science or anywhere, if you are able to, if you have a potential to convert that problem in mathematical institutions intuition, then you can solve that problem, and then again back to the your context, either it is physics or electronics or anywhere. So mathematics is a language of science, you can say, that is what it is. Okay, so this I think this is a this makes
And
it clear that
sir, one
what is
more
the.
thing I want to mention.
Mhm.
So in the signals, the book from BP Lathi of Signals and Systems mentioned that complex numbers comes from solving cubic equation and not like x square plus 1 equal to 0 kind of equations.
Mhm. Cubic equation, even I will say, okay, so no matter. So if you see it here, I am saying to be x cube is equal to 1. Let's say I change it here, or even let's say x cube plus 1 is equal to 0, minus 1, even yeah, even let's say this, even I am writing x cube minus 1 is equal to 0. So this is a cubic equation. What I will substitute, what is your answer here? What you will give your answer here? You will say x is equal to 1, right? But I will say here there is another roots, that is called cube roots, not only one. There are the roots which are in the complex. So see, this is, you are saying this is, I'm saying it came from here, but it's depend on the, you know, it's depend on even some writers or professors, it's depend on how you are bringing the complex number. I brought this here from here, the to understand okay how it is, but it came also from here. So not only x is equal to 1 the answer, there are two complex number also. You will see more detail nth root of unity. You will see the nth root of unity in here itself. Omega is there. Okay, so it's depend on the professor writer how he bringing this complex number. Okay, is it clear?
Yes, sir. Yes, sir.
Okay, so this is the complex number. I will this complex number will see in more detail, I think in maths one already done, right? The complex number, yeah, I think so. Just recap and recall. Also I am doing this, just a recall that a complex number are actually representation of this one, okay, of this case, where the absolute value is saying to be. So here is the one representation is that, let's say this part, this a is coming from this real real part, you can say this is called real part, and this is called imaginary part. Okay, so the real parts you can, as you have seen the coordinate system here, the notation you can see, and the imaginary part you can note the number here. Let's say I'm saying 3 plus, right? 3 plus I5, so I can denote it 3 here and 5 somewhere here, and the exact complex number here, it is going to be the complex number, the representation is actually here, which is here, the it's represent the real on the real part, this represent on the real part here, and this represent the complex part here. And this line you can say the imaginary line, you can say this is a imaginary line and this is a real line, you can say. That is what the real line and the imaginary line, this part you can say the imaginary line, or you say this is the imaginary part, the is coming, this is the real part. This portion you can say the imaginary numbers is there, and here is the real numbers are there. So many terms are there, it depends the professor and professor how he is writing, the meaning is same.
Sir, can I like in the for this complex number, can I say this complex number is a linear combination of the real part and the imaginary part?
Yes, that is what is it. This is a combination of real part and imaginary. This is a linear combination. Yes, this is a linear combination. So that is what now next is we are going to see, and I think that's enough to know about the complex number. A bit about is also that absolute value is there, which is of how much. So absolute value is the representation is this, means how this number is away from origin. This is your origin, you can say 0 plus 0 I, you can say, okay, 0 plus 0 I. So how much, what is the quantity here? This is the distance, you can say how much this is away from here. So the representation is exactly how to find the distance between 2 points in the coordinate system. That is exactly same. If you see the formula here is a square plus b square. Okay, this is the absolute value of it, and there is a conjugate also is there. The conjugate is what is there, means a reflection with respect to the this real line. Means let's say I'm saying this is our z here, or this is, I'm saying this is my z1. So z1 conjugate representation is z1 bar. Z1 bar, which is nothing but if you change just 5 with the 3 plus I, 5 with, sorry, I with minus I, and the 5 is going to be same. Means the real part, whatever here is, it is the same, but this minus is going to be added. So minus side is this one. So exactly 3 minus I 5 it is. Means here image, or this you can say your mirror is on the x-axis and you are taking the image of it. That is what it is. Or in different word, this is the conjugate. The conjugate is nothing but if you have z is equal to 1 plus ib, so the conjugate is going to be a plus a minus ib. Just replace I with minus I. So conjugate, absolute, real number, representation, and that's all. That's enough to know about the complex. We'll not go detail here in the complex. I think you have studied, or we are anyhow we are going to see in the. I said no, we will see there in more detail the nth root. So you will see also nth root. You will see, I think, in week 11, 12. So that much idea is enough to know about the real and complex. Why here the complex we started? Because we will see the vector space of complex number also, Cn. So C2 also we'll see. So we will discuss that. So let's start now the vector space. Okay. So what is a vector space? So vector space is, as you have, the real numbers, right? You have a real lines, the real numbers. So you can add two numbers. Okay. You can, here is 0, let's say here is a and b, so you can add two numbers, let's say a and b. If you are adding two numbers, it will be somewhere, let's say this is 5 and this is 3 and 5. If you are adding these two, somewhere 8 you will get here, a plus b, which is 8. Means you are able to add this number, and which is adding to with these two, it will actually represent this number. Means you are able to play with real numbers, right? You can add, you can multiply, you can subtract. So what it means that it's saying to be, real numbers is, it is a kind of, real number is a space, right? Like it is your, suppose it is for the time being, suppose it is your home. Let's say this is my home. In my home, I can do anything. I can walk, I can play, I can eat food, so whatever the number of things I can do. Because this is my space. That is the meaning of it. This is my space, I can do anything. Like this is here, the real number. I can do anything in that. I can multiply two number, I can add two number, I can subtract two number, I can divide two numbers. Yeah, what is happening here? If I will multiply, I will fall on the real line, right? When I am adding, it represent on the same 8, right? If I am adding or multiplying, if I multiply 3 into 5, which is 15, which is somewhere here on the line itself. See, on the line it's happening. Is it happening somewhere? You got 15, which is representing here? No, right? It is not. He is not leaving this line. Below his home, it's happening. Like here, I can do n number of things. I am only in the home, or whatever the, you can say, the environment. In my environment, I can do only. I'm not going to space, right? I'm not do the things in space. I can do on earth only. I can do n number of things on earth only. So that's the meaning of space. That's the meaning of space. You are not, once you multiplied, you are not leaving that line. You are within the line. If you divide that, it will also within the line here. Some number represent. It will represent some number. So this is the meaning of space. Means in own space, I can do n number of things. The same way here, what is a vector space means? Let's say I am representing a number like this, a and b. Right? Okay, I am representing. See, I am saying a representing. Okay, this is just a representation. Okay, I am representing like this the number. Here the representation is just single, but here the representation is like 1, 1. Okay, so here this part is coming. Let's say this is one real number represented only a comma, and then the second real number. So this is a representation. I am represent. This is a one represent. This is another representation, not another. This is a new representation of two real numbers simultaneously. This is a new representation of two real number simultaneously. So here is, you can say R, one R is for this one, and here the comma is, let's say I'm replacing by the means the notation is actually this is from here. It means that you are taking the first coordinate from this real, and the second, this is called coordinates on this argument. You can also, the second argument I'm taking from this real number. Okay, I am taking two real numbers like this. This is a representation. Okay. Now I have some number. What I can do? Is there any meaning of adding 3 and 4 to I am another representation of this? Because this is a real number, right? So here in place of this, I can put anything. I can put anything. Okay, and this is what it is. So generally, the mean to say here is one blank, and here is one blank. I can fill this blank by R. I can fill this blank by different R, which is the meaning of same but different R. Okay, okay, and this is R what it is. So this is just a representation, and this is called your art. This is called your art. Okay, so I can fill in this box with any real number. So let's say I am filling this box as 1, and this is 2. So I am getting 1 and 2. I can fill 3 here and 4 here. So I will get another 3 and 4 number representation. Some another. So I am saying, let's say this is my V1. I am saying this is my V2. Okay. So let's say here is I am adding V1 and V2. So this is not as you usually you add 2 and 3 in real number and you add it. So here adding means, see, there is so many ways to add. There are so many ways to add. I can add this 1 and 3 here, or I can add 1 and 4. But there is a standard way to add so that it will reflect a meaningful thing. Okay? So what is the meaningful thing is there? Let's say I am adding this one with this one, and this one with this one. So how I am adding 1 plus 3, comma 2 plus 4. Why I am adding like this? The reason is I want a meaningful thing. I want a meaningful thing. I want to build a space that is called your vector space. Okay. Even I say, let's say I am adding 1 plus 4 here. I added to this one 1 plus 4, and this to this, comma 2 plus 3. Okay. But when I added, I analyzes, not I, mathematician, I mean to say, when mathematician analyze, this will not reaches to a meaningful space. And they end up with, let's finish this and let's do by this way. And they reaches to a meaningful thing, and they expanded slowly the whole thing or whole concept, basis, dimension, or everything is coming from here. And that they said, okay, this kind of operations form a space. Like, so I have collection. Now let's say I have a V where collection of these numbers. I have collection of these, not numbers, this representation. I have infinitely many this. See how many I can build, because I am saying this is a box and this is another box. So I can fill any here. I can fill this one is anything, right? So there are n numbers, no n, infinitely many, sorry, infinitely many. So this V is actually going to be infinitely many. I am here defining some plus thing is between these two. I'm defining this plus how it's happening, as just now I defined 1 plus 3, 2 plus 4. This is how it's defined. There is another thing in that set. I am defining this dot. I can define anything, but I am defining how it is. Dot is there. So dot is not the way it is doing dot of this one. Okay, this is not defined there. Okay, they not define this one. The mathematician, they didn't define this. They define, let's say I am taking a real number alpha, let's say 5, and multiplying with this representation. So in place of multiplying dot, you can say here this dot is there. You will see the inner product with the different also, but here is this means this. Or let's say if you have problem, let's say I am changing the sign. So the definition for multiplication is defined as only one real number and this representation. And how it is defined? 5 into 1 and 5 into 2, which is 5 comma 10. They didn't define like this. Okay, there is no definition. You will see this definition means here dot thing later on, that is called inner product. But we will define this representation separately. But here for week 1 and 2 we are going to study by this way, like multiplying a real and this vector. This is called vector. So this is called vector. I didn't mention it. This I am saying representation, no? So this representation is called vector. This is called vector. The name you can now see it's coming, the word you have seen the vector, you are relating with the vector in the physics. But whatever we are studying and whatever you studied in physics, okay, I will not say the different, okay, not different, they are not different. But here what we are studying and whatever you studied there, you studied in the physics in the context way. Like I have a vector and displacement, these things you studied. But here in mathematics you are going to study with the numbers only. Okay? But bracket meaning is same, but we are not going to discuss that. Okay? We are not going to discuss that with the physics. And here we are going to see only the output, means not going to means numbers. We are play with the numbers only. Here we are going to see the, I am saying this is a vector, but this is just a name. But we will play with this number like this. Playing means I am playing, right? I am a scalar multiplying with this vector. I have one vector, another vector, I added these two. So this is the meaning of it. We are going to study this case only, not with the physics context. You're not going to study that. That is totally different. There you will study some, maybe you will see in the electronic system somewhere. But if you see what I am saying, backend is same. You will relate the electronic system thing just now to here. Some Aniket has asked, right? Something is there. So the thing is same, but let's first understand these terms so that we can relate the physics thing and maybe electronics thing and this one here. All of you are very silent. I don't know what I am speaking continuously. I am speaking. Is this understandable? Sorry for.
No, we're getting it.
Yes, sir, got it.
Is this boring or anything?
No,
I
no,
don't know.
No, sir, interesting.
interesting.
Okay. So see, so why I am starting from here, no, so that you will be in the comfortable. So you'll feel comfortable because you are now going to see a new representation. See, this is a new representation, no, but don't feel it is a new. It is actually built it, but just follow the way it is here. Means you feel it new, that is fine, but this is a not new. Okay, this is a built new. So how we can learn this? Just follow the definition. Now see, from here you will understand the meaning of definition. It's mathematics. Definition is a very important. See what I am saying. Define, right? I define the addition like this. I define the multiplication like this. Define means definition is given. Defining means definition is given. So you cannot do your own way. Okay, you cannot do your own way. How the definition is defined, you have to follow that rule, and you have to do. Okay. Whatever till 12 you studied in mathematics, already built it. The professor said solve this link, solve the equation, sine value, cos value, add numbers, divide with numbers. You studied only those, or have studied the continuity, difference, build continuous, derivative value, derivative you studied, right? But what is in backend happen, you didn't see ever. I think you in maths one you have seen the calculus, so you able to realize that the derivative meaning is not simple. Where whatever you studied, like you are used to derivate x cube. If you do what is dd of x, you know, right? Only 3x square. But what is the meaning of here in mathematics is actually came from limit something, right? You have seen that from calculus. So in the back end, very broad mathematics is there. In upper side, you are looking, okay, very simple formulas are there. Okay. So in physics, no, you can say the upper part you will see of this linear algebra. But in back end, that is what you are going to study, the back end thing of the physics one. That is the language thing, you can say. Means here, so defining means I emphasis on the word define. However it's defined, just follow that rule. Don't make your own rule. Means here, it says it is not defined that this one, so don't follow that. Okay, I can multiply two vectors. I cannot multiply. I can multiply a scalar. See, maybe you are fear with the word scalar, but here scalar means that just a real number, just a number. I'm just taking a, I'm just calling it as a scalar. Okay, so I'm saying I'm just calling a vector. You can say it representation. You can call it as just one, two. You can call it no matter. It's your own. Okay, but I'm saying this is a vector. Let's say this is a vector v1 and another vector v2. I am calling this is a real number, right? You know the real number, but I am just giving the new name scalar. So you can multiply a real number with this representation. Means scalar you're multiplying vector. So multiplication only defined by scalar and multiplication, not two vectors. This is not defined. Scalar and multiply, you can multiply and get. Here similarly, this one. I can add two vectors. That's all. So I have a n number of set, right? So this representation, this V, you can say your R and cross R, which is your R2, right? This is your R2. First, this is the box and comma, this is the box. This is one R and this is another R and you multiply it. So this set is nothing but your this V I form. This V is your R cross R, which is R2. Okay, and I am here. I have these numbers, as you know. R is actually what? R is your 0. This is 0, and this is what the real number. This is what the real numbers, right? Similarly, your R2 is exactly this one. Yes, your R is there. I can here the addition is defined 3 plus 5, 3 minus 5. Similarly, here is also I am defining the addition v1 plus v2. Yes, there is not defined multiplication, but no need to worry. Later we'll see. Okay, I think week 9, 10. But no need to worry. Yes, there is one multiplication, scalar and vector. Scalar, let's say 5 and a vector. This multiplication is defined. And how it's defined, we are discussing that already. Coordinate wise, argument wise, multiplied. So this is your R2. Okay, this is what the vector space. So I have a R2 means I have this. R2 means nothing but your representation of this collection of this representation, collection of this representation. Okay, and the addition is defined there, and dot, or you can say this one, whatever you can say. Both are one. Either dot you can say, or this cross sign is there. So this is defined on these numbers. Okay, as in the real numbers it is defined 0, 1, 2. The addition is defined there. Yeah, there is, you can see the minus is there, but there is no minus. Minus you can in doing in place of minus, there is not defined minus. In place of doing minus, I can writing the numbers as a -1 and we can do. So only two operation and these two are defined here. Okay, here in real numbers, so many like plus, dot, division, a by b. Okay, so many things operation are defined here in R. But in this here, only two fixed things are defined: plus and dot. And also dot is very specific. Scalar time the vector. Here is addition of two vector. Only these two type. Using these two operation, some set of rules are there, as the rules in already you have seen in R. Same rules are there. It will follow that. Some set of rules you can see that what are the rules. The rules are saying to be, if you want, I can write the rules. Uh, so okay, let me. But there is no meaning of writing the rules. Uh, do I need to discuss that? Mhm. because it is not needed. I am just making your base that okay, this is your R2. Okay, and knowing to the rules are yes, let me write that. I mean to say, when you added no these two, see I said no when I multiplied or added on the real number, let's say this is a, this is b, it is actually falling on the same rail. So when I add, the first rule says when I am adding v1 plus v2, this will be in the same v, and the second rule says when I am multiplying scalar with a vector, this is going to be in same v. Same v is your r2. Okay, it's r2. And there is one identity is there, means zero vector, that is called zero vector. So see, you have no, we have in r zero is there, right? In r zero is there, so both argument I fill by zero, so that is your zero element. So zero element is there. Fourth rule is there. Fourth rule is there. You can multiply 1 and 5 will get 5, right? So I can multiply 1 with any vector v, I will get v. That is your fourth rule. And here is I can zero, I can add this with the any vector, let's say ab. So if I will add, so 0 time a, sorry, 0 plus a, 0 plus b, which is nothing but a comma b, right? So same thing you are getting a comma b. Once you added zero vector, you are getting the same. I'm multiplying this is what I am getting. Yeah, this is 0 time addition, scalar multiplication, these things are there, zero vector is there, and this is there. And some other rules are, so these four rules are important. Now the fifth rules are, you can say, uh, uh, this fifth rule is actually I have this one v1 and v1 plus v2. Some scalar is not vector, like because multiplication is defined for a scalar. So in place of dot, I am just removing dot. I am just simply doing. So this will be alpha v1 plus alpha v2. The sixth rule is that it will be spread out, only just spread out. I can add v1 plus v2. The associative law, I can leave the first one and add v2 plus v3. So this is v3. The next is this one. The last eighth, there are 8 rules actually. The last one is yeah, v1 plus v2 is equal to v2 plus v1, both are, it is actually adding to the first one, second one is going to be the same. So let me show you that where is the some set of rules, so that if you are looking the lecture later, you can relate to that. So why I'm not going so detailed with respect to the rules, I will tell you that why it is. Factors, it will, yes. See, the representation is no. Okay. Till now, remain to tell you the representation. I will tell you the representation. Okay, he didn't tell you. Okay, so no need of it even. So that is what I, no need of it in these rules. Okay, just knowing to be enough, but these rules are not needed. So see, these are the vectors. So now let me tell you the representation. So you don't want, actually don't need it. That's why even professor is also didn't discuss that. That is not needed even. Some set of rules are there. Okay, means these rules are actually followed. So whatever the rules are, I have mentioned it. No, these rules are actually followed by these R2 elements. This representation. These rules are actually these elements will follow. Okay, and these elements are called vector. Okay, these elements I am saying the vector. Our representation, how it is, the representation, let's say this is your r and this is your r. That is what here it's happening. This is r, this is what you can say the r cross r, it's happening. Now This is one argument I have taken. Let's say I'm writing. So here is, maybe you are fearing with the, I am writing the vector like this. Okay. So vector is actually could be written as like this. I can write, or I can write a vertical matrix. Both are same. Okay. No need to worry. Don't worry. These two representation there, 1 comma 2 or 1 comma 2. Both are same. I can represent like this, or even sometimes represented like this also. Okay, but more standard form is either you can follow this one, or is the most general is this one, which is professor is follow. The vector is this one. Okay, so your R is nothing but your R2. Sorry, R2 is nothing but collection of these vectors. So that box, let me make. You can fill with any real numbers these boxes. These are the collection of vectors. Okay, now I am representing this vector 1 2. What it means that this first one is go with this one. So let's say somewhere here is 1. Okay, and the second 2 is somewhere here. So on the second argument will lie for this vertical line as with the complex line. So here we are not going the complex, we are doing now on R2. So this number is for 1R, then this is for this one, and 1 and 2 is finally represent here. The vector represented it here. 1 comma. This is your vector, and how it's represented. See, this is the representation is actually. So I am saying this vector. Let's say 3 4. Let's say I am saying the vector. Okay, so here even here itself. So 1 2 is the vector, the quantity, and the finally arrow direction. This is your quantity and this is your direction. 1 2. So 1 2. The vector is 1 2. Here is, let's say I am again saying, let's say I am representing 3 4. That means the representation how it is going to be. So here is going to be somewhere 3 and here is going to be 4. So it is going to be here. So this is 3 4 here somewhere. So the vector 3 4 is your the vector 3 4. So representation in graphically, the representation is like this. This from origin to this, the distance how much it is, and this, and what is this distance. This distance we'll see later, but the representation here is this one. Means a vector representation like this is what it is. So my question is, maybe there is one. Let's say I'm saying, okay, let me represent the adding vector. So let's say I have vector 1 2. I added with vector 3 4. So I added, so addition I defined, right? This one is added by this way, this one is added by this here. So if you add 1 plus 3 and 2 plus 4, which is going to be 4 and 6. This is what it is. But in representation, how it is? See the, let's see the representation. So 1 2. So 1 2 we have just seen. 1 2 is somewhere. Okay, not this much. 1 is going to be somewhere here and 2 is going to be somewhere here. So here, let's say here 1 2 is, this is here my 1 vector and 2 vector, and 3 4. So 3 4 is going to be 3 somewhere here and 4 is going to be somewhere here. Here it is. Not this much. Here. Let's say here is 4 is here. 3 is here. So this is your vector 3 4. So when I added, so what is I got this vector. So how it's added? So it's added by parallelogram law. So what is a parallelogram law? Parallelogram law means, see, what I added, this is itself called parallelogram law. This is called parallelogram law. But in representation, how it's adding, how I'm adding. So parallelogram law is saying, so take this vector, okay, take this vector, how its direction, maintaining that. See what I'm exactly, I'm taking this vector, okay, and I substituted here with maintaining direction. I just took this and maintaining the direction. See, I'm not, maybe it's look like changing the direction. Let me not, I'm maintaining the same direction. See, I'm just taking this vector and replace the here. See, when I replace the here, and finally how it is now, if you gauge this vector, if you gauge this vector exactly, the distance is going to be the vector, you will get exactly this one. If you gauge here, this is going to be exactly the same. So I mean to say, if the representation is, I'm very bad in drawing. So the thing is that, let's say this is a vector and this is another vector. When it is added, so let's say you can take this vector exactly and put here exactly the same. So this is how it's added. See, the direction is same, quantity is how much height is this one, exactly the height is same, the direction is also same. So this is what it is added. So now gauge this. So this is your added direction finally. This is your finally added direction. This is called your parallelogram law. What is means, I am not changing the direction and quantity, how it is just shifted to here. This vector I shifted to here, and this is what it's added. So whatever the vector you got, this is your vector finally. Means this is your vector. Please stop me. Please stop me. If you are not getting it, this addition, the representation of addition vector is this one. Please stop me if you are not getting. I will try to with the different method. Is this understandable? I don't know.
Yes, sir, got it.
Yes, I was cutting it.
Okay. See, I spent on this much time on here. Now I will slowly move fast. So now I will slowly move. Uh, so this is the vector thing is there. Means addition of the vector, how will add, how will see the addition of, how is defining parallelogram law. By the parallelogram law, that is what professor is mentioning, a parallelogram rule, adding the vectors. So everything is follow that way only. Multiplication, what is going to be, then the question would be, one question would be asked, how the multiplication is happening. So multiplication, let me say that, let's say I have vectors, the same vector 1 2. Let's say I have vector here 1 2. So I multiplied, let's say I'm multiplying this vector by 3 3 1 2. I multiply, so this is going to be 3 times 1, 3 times 2. So I multiply, this is going to be 3 and 6. So what is happening here? So if you see, so if you draw 3 and 6, so somewhere 3 is here, somewhere 6 is going to be somewhere. I made it badly. Here is 1 2 is, the proper representation is this one. So let's say here is 1 2. So 3 is somewhere here is going to be, and 6 is somewhere here. So finally somewhere, no, even that is not also. So maybe 3 is here according to that 1 2 3. So this much height. So see, this is going to be, if you draw 3 6, it is going to be somewhere here. But if you see exactly, it is just extension scaled up. This vector is just scaled up. So
It's
you
in the
have
same
to get
direction.
it same direction. It is maintaining the direction. Just
Right.
height is bit head, because you multiplied, the quantity is now more, you multiplied that. So it is maintaining the direction. Yeah, it contain more quantity but have the same direction. That is what the scaling scale. So scalar multiplication is just scaling up and down the vector. It is not changing the direction. This is the representation of scalar multiplication. Okay. So now I think now everything you can now relate it. So slowly, let's move on the concept of linear combination. So this is what it is: the is adding the vector, and we have seen by the representation also. Sorry, graphically we have seen, visualization we done. Now there is one concept: linear combination. What is a linear combination? So let's say I have R2. What R2 means, the set it is, the set is this one. Let's say I'm now writing as the professor is done, column wise. So these are some number, let's say some numbers is there, some numbers. So means here, this is the vectors I have. Okay. What I am doing, let's say I'm saying this is my V1. Okay. And I'm saying, let's say this is my P2. Okay. So let's say this is, I am making it like this properly. Let's say A1, B1. And let's say I'm saying this is A2. I'm taking randomly two vector V1 and V2. I took this randomly vector. I am okay. So what is a linear combination? So the question is, I'm writing the linear, the word properly. I'm linear combination. I'm writing properly word. Okay? The sentence I'm properly writing a linear combination of v1 vector and v2 vector is, what is this one, is, let's say, scalar. Let's say scalar, I'm saying, no, scalar means some real number. Let's say I'm some real number alpha I'm saying, and some real number beta I'm saying. So alpha time v1 plus beta time v2. What it means that, so see the word or sentence here. The linear combination of v1 is v2 is this. What it means that, let's understand by example. So let's say I have a vector 1 2 and another vector. Let's say this is my v1 and I am saying v2. Let's say 3 4. I have these two vector I have. So linear combination of these two is nothing but alpha time 1 2 plus beta time 3 4. What is alpha beta? Linear combination. What is alpha beta? Alpha is real number. So one linear combination of, let's say I am substituting now, alpha is 5 and beta is 2. So 5 the vector 1 2 plus 2 the vector 3 4. So which is going to be, finally you can just multiply and add them. So this is going to be 5 and 10 plus 6 and 8, which is 5 plus 6, 10 plus 8, which is 11 and 18. So you can say, see, you got this vector, right? You, whatever the new vector you got, 11.18. So you can say this vector you got, let's say I'm saying this v3. V3 vector is a linear combination of these two vectors, or you can say this v3, this you vector you obtain, this is a linear combination of these two vectors, these two vectors. So finally what it means, that it means that I have some vectors, I just multiplied, added them, whatever the vector I got, that you can say that is a linear combination of using these two vectors. So by this way I can generate any linear combination. So this representation, I mean to say, the definition is, this representation is called a linear combination of v1 and v2. This representation, or this operation done, finally this, this whatever the finally output you get, you can say the v3 is linear combination of v1 and v2. This is the meaning of linear combination. Okay. So I let me, you can understand more by this way. by creating a problem. I'm creating a problem. Okay, there is a one question. Let's say I'm questioning: is the vector 3 4 is the vector 3 4 is the vector here 3 4 is linear combination of 1 1 1 0? This is the question. Is the vector 3 4, so is the vector here is 3 4 is linear combination of this one? This is now the thing is that you understood the concept, you understood the meaning, but now the see question: how I will get that this vector is linear combination of these two? How I can check that? This is now the question. How you can confirm this vector is linear combination of these two? What it means that? Anyone can answer? What it means that?
I think no, sir.
Yes,
There's no combination.
it is combination or not? What it means that? The thing is, I'm saying is the vector this one is linear combination of these two. What it means that? It means that as the definition now, follow the definition. Follow the definition, or even a linear combination of V1 is this one. Or I am slightly changing the definition. I will say that this is another definition. The V3 is said to be linear combination of V1 and V2 if alpha time V1 if there exist, this is the sign of word there exist, it means that there exist. I'm writing the short form of there exist word. This is there exist alpha and beta are, yes, such that, this is the sign of word such that I'm writing in short form. You can write the same word such that V3 is equal to alpha V1 plus beta beta V2. Means I am able to get some alpha beta, some scalar. Is there somewhere a scalar alpha beta? I can able to some scalar. I am able to get some alpha beta such that I can write V3 as V1 and V2. So, this is what the question is. 3 4 is the linear combination of this one, these two vectors. What it means that I have to find alpha beta. I have to find that alpha beta, so that when alpha time 1 1 plus beta time 1 0 I am getting the vector 3 4. I'm able to get the vector 3 4. This is what the meaning of linear combination. See, this is you understood different, not differently. This is the meaning of saying the linear combination. But slightly, I just wrote this definition. I create a question, and see the question is now of are we able to get alpha beta? So this is simple now. So let's assume. Let's assume there exists alpha beta. Let's assume that there exists alpha beta such that this one. So now let's solve. This is an equation, no? This equation between the vectors. So this is going to be alpha plus beta. You can multiply beta and 0. Beta times 0 is going to be beta. And this is 3 4. That means, so I can change by, I am in place of writing, I can write this one also. Understood, these are same. Okay, sometimes for me to easier, I can write like this also. So this is a finally alpha plus beta. Okay, and this is alpha plus 0, and this is 3 4. Okay, So it means that this one is, these two are same. What it means that in equation form, this alpha beta is 3, and this alpha plus 0, which is nothing but just alpha. Alpha is 4. So see what it means, that you got a system. So this is a system of linear equation in variable alpha beta. This is a system of linear equation. Now see the hardcore you reaches to know hardcore. What is the hardware? You study the system of linear equation, okay? But see, the understanding the linear concept, linear combination concept still reaches now the solving the system of linear equation. Now what is going to be solution? Here the alpha is going to be 4. And once you alpha is 4, so you can substitute in this equation. Beta is going to be 4 minus alpha, sorry, 3 minus 4. 3 minus alpha, which is 4. So this is minus 1. Oh, is this wrong? Okay, 1 minute. Yeah, no, correct. This is correct, I think. Yes, this is one. So that means what? If I, in place of alpha, which is 4, we got 4 1 1, and beta is minus 1, we got, and 1 0. See, if I will solve this, what is going to be 4 4 minus, so minus 1 is, you can write like this, plus this minus 1 is there, no, that means your minus 1 you can multiply inside. That is what the plus thing is there. So 4 minus 1 and 4 plus 0, finally you will get, which is 3 4. See, yes, I am able to get such alpha beta. Alpha beta is there, exist. Yes, we are able to get. We verified also. Yes, alpha beta is there. So that we got also in this form 3 4.
Okay, sir, got it.
Yes, sir,
Got
got
it?
it.
Easy?
Yeah,
Yes,
but
What
sir.
is the meaning? You understood the concept, but without doing problem, it would be difficult. And this is
yes,
what is going to be in the linear algebra. It's look like easy, not it. Sometimes it also going to be tougher. Many student value, when you come to eigenvalue, eigenvector, when we start discussing eigenvalue, eigenvector, you student used to get, okay, this is what determinant we are fighting, and I finding the root of that. This is so simple. But when they started solving, they start stucking. Like, what is the going to be the next? What is going to be the next? How I will solve? How will I will find the root? What is geometric multiplicity? What is algebraic multiplicity? But this could be understand by just do more and problem. So see, I ask this by one problem. This is a simple problem. Even on the definition itself. This question is on the definition itself. Suppose I just twist it a bit. Let's say I mix with another concept. Then what is going to be then now? So that is needed more in-depth knowledge in that. So it's needed. You have to understand not only by upper part. You have to solve more and more problem, so that you will get in more detailed way, a different approach, not different dimension of the definition. So this is a linear combination, and that's all. We even not able to finish half of the, how many lectures are there? 6, 7, 8 lectures are there. So now today's just now 2 hour done. I'm not will take more time now. In the next session we'll discuss more and more thing. Okay, so yeah, lecture 6 is discussing about whatever we discussed today, more definitions, right? I some set of rules I have given. No, that is what here the set of rules. That is what here the set of rules. Here, it's actually we slowly discuss lecture 6, but it should be, yeah. He started representation, span, and then define the vector space. I started using the definition of vector space, and slowly rest all we. So in my suggestion is that is what, before to coming the lecture, see the whole lectures of that particular week. Maybe sometimes it may easier to be discussing some particular lecture, maybe 3 4, and then coming back to 1 2 lectures. It's depend on how I will feel to teach you that, so that you will understand easily. See, this is what it's a meaning. See, whatever we discuss, 8 rules I wrote. No, 8 all rules are now professor is mentioning in the 6th lecture. This is what all 8 rules are. So you can see it. So maybe we covered only 2 lectures. I think 3 lectures. Span is remain linear combination. That's all. This one 3 lectures we cover. Okay, slowly we reach just to half. 6 already we discuss. So in the next lecture we'll discuss that span and yeah, linearly independent. That is not tough. If you understand here only whatever today we discuss, no, these all concept is going to be easy for you. Only slightly difficult maybe basis, but linear dependent, because this linear dependent independent itself actually this one linear combination. Listen, whatever we just now discussed in more details with the solution. This is nothing but a different word, you can say. A naming is a slightly different definition is there. So at half of the reaches, but not more than that. We'll discuss in the next session.
Okay, sir.
So my suggestion is please again go through with the whole week lecture, so that whenever I will start discussing, before that you can ask me some question. Okay, I didn't get that. I didn't get that. Could you repeat, please? I solved this problem. I stuck here. How I will solve? That is a more enthusiast also for me. It will give more enthusiasm for me to discuss with you. Okay. Thanks
Okay, sir.
everyone. Thanks for joining. That's all from my side.
Thank you,
Before to
sir.
end,
Thank you, sir.
anyone have any doubt? Anyone want to ask something?
Sir, are you gold medalist?
No. I'm
So I saw
graduation.
that in the LinkedIn profile.
Yeah, I was in graduation. Yeah,
Oh,
in BHU I was. Yeah, in MSc I'm not.
okay.
Okay. Thanks everyone. Thanks for joining. We'll see
Thank you, sir.
in the next session.
Thank you, sir.
Thank you, sir. Thank you.
Okay.